Hey, good morning, guys. We're going to be talking today about the structure of the atom, and more specifically, we're going to be talking about how to find the number of protons and the number of neutrons in an atom, and what it's called when the number of neutrons in the atom change, but the number of protons stay the same. When that happens, we get an isotope. Okay, so we're going to be looking at really three different things today. First, we're looking at the models of the atom tutorial in Plato. That's what I'm looking at currently. I'm on slide 18. And then eventually we're going to switch over. We're going to look at isotopes and atomic mass. I'm skipping all the way and starting on slide 3. So this is just the next tutorial here. So we're going to kind of do a little bit of each tutorial. And you should complete both mastery tests, both tutorials and both mastery tests for these topics, okay? So do that, as well as the isotope practice worksheet that is also included in this lesson. You'll have Thursday and Friday to complete this. So Thursday or Friday, whatever day you take your STAR test, you'll take the STAR test, and then when you're done with that, you'll work on this. And so you have about a day and a half to do these two things, okay? So let's get started. Let's talk about this. So the structure of the atom. So as we talked about before, an atom is made of protons, neutrons, and electrons. We're not even going to worry about electrons today. We're not even going to talk about them at all. What we're going to focus on is the protons and neutrons. So protons and neutrons, they're in the center of the nucleus of the atom, and they pretty much make up all the mass of the atom. So the mass of the atom is basically the number of protons plus the number of neutrons. If you ever hear what is the mass number? Mass number is the number of protons plus the number of neutrons. Okay? Atomic mass is a little bit different. Atomic mass is a weighted average of all the isotopes of an element. Okay? Now, isotopes are when the number of neutrons change, but the number of protons stay the same. Okay, so number of protons really determines what the identity of an element is. So the atom's element identity is identified by their atomic number. Their atomic number is the number of protons. For example, hydrogen has an atomic number of 1. It always has 1 proton. Okay, helium, atomic number 2. It always has 2 protons. Okay, lithium always has 3 protons. Okay, so that never changes. However, the number of neutrons can change, so the mass can change. Okay, so if you look at the periodic table, if you look at a periodic table like this, the number on the top of the element symbol, that is the atomic number. So that is what tells you. So this 3 here, lithium always has 3 protons. Beryllium always has 4 protons. Boron always has 5 protons. Okay. So that's the atomic number. That tells you the number of protons. That never changes. Okay, never changes. Okay, the bottom numbers, the number on the bottom, this is atomic mass. Okay, the reason that it's not a whole number, is because it's actually an average of all the isotopes. So, for example, magnesium can have isotopes that weigh 24 atomic mass units, or can weigh 25 atomic mass units. And the difference between those two things is the number of neutrons. Okay, the number of neutrons can change. Okay, so let's get back to the tutorial here. So there's a couple different ways to write. There's a couple different notations to write and describe a specific isotope of an element. This is just one way. In the isotope practice worksheet, I gave you a little bit of a rundown here. One way to do it is by writing the name of the element followed by the mass number. So that's the mass number is the number of protons plus the number of neutrons. Okay, so there's carbon 12. It has 6 protons, 6 neutrons. Carbon 13 has 6 protons and 7 neutrons. Again, the number of protons doesn't change. So if we're adding another mass unit, it must be because we're adding another neutron. Okay, so carbon 14 always has 6 protons, but because it's 14 now, it must have 8 neutrons. So these are all isotopes of one another. They all have the same number of protons, but different number of neutrons. Okay, so that's one way to write it. The other way to write it is this shorthand notation. So the top number would be the mass number, and the bottom number would be the atomic number. In your homework assignment, if you ever need to write a fraction like this, what you're going to do in Google Docs is you go to Insert Equation, and then this little thing will come up, this little menu will come up, and you're going to click on Math Operations, and then this fraction sign. Okay, and now you can write whatever you need to write. That one, and then just hit the down arrow, then just hit Enter, and you'll get to the bottom one, whatever you got to write. The top number should always be bigger. I don't know why I wrote the bottom number bigger, but it should always be bigger. But anyway, that's how you do it. So again, insert equation, new equation, and then the fraction sign here if you need to do that for your homework. Okay. All right. So the first part of that is just telling me find the isotope name, tell me what the atomic number is. So you can find the atomic number from a periodic table. So just find a periodic table on the internet. Doesn't matter where you get it from, they're all the same. Okay. And then the mass number would be the mass number is just this number. Ooh, that's so easy. And then the number of protons is the atomic number. The mass number minus the atomic number, and you get the number of protons. And the number of neutrons is the mass number minus the atomic number. You'll get the number of neutrons. Okay, so you should be able to do that. That should be pretty simple for you. Okay, and so again, this notation here, if you want to do it in the tutorial, great. I'm not even going to go through it. You can work on that your own if you want to. You can skip over atomic orbitals. If the mastery test has any atomic orbital ones, don't worry about it. Just skip over it. I'm just gonna give you a pass fail for doing this mastery test. This is not going to be a graded mastery test. If you do it, you get credit. If you don't do it, you don't get credit. Doesn't matter what score you get. You could just answer them all wrong. I just want to see that you at least tried on it, okay? Because we're not going to talk about atomic orbitals at the moment. We'll talk about that another time when we talk about the periodic table and electrons, because atomic orbital has to do with electrons. And we're not going to talk about electrons at the moment. Okay, so that's it for the models of the atom. We're going to move on to isotopes. So again, isotopes, as I said, they're atoms that have different number of neutrons but the same number of protons. So for example here, carbon, there's 3 different isotopes of carbon, carbon 12, carbon 13, and carbon 14. They all have 6 protons, as you see, but then the number of neutrons differ. Okay, 6, 7, 8. So 666, 6, 7, 8. Atomic number 666 because the same number of protons, and then the mass number changes. Okay, that is the definition of isotope. Okay. Now isotopes are used, so you want to practice this, you can practice this, great. Isotopes are used for dating things because a lot of isotopes, so if you want to watch this video, great. Isotopes will lose their neutrons. So like carbon 14, over time, it loses its neutrons, okay? And it takes a specific amount of time for them to lose their neutrons. And we can use that information to date things, to figure out how long something has been dead or how long has it been in the ground, right? So we can use radioactive dating to figure out how long something's been there. And that's a lot of what we use radioactive isotopes for. Okay, I'm going to skip through a bunch of this stuff. We also use it in things like smoke detectors and radiation treatment to kill cancer cells and all that good stuff. So I'm going to keep going here. I'm not going to do all this if you want to. So dating bones. Bones are typically dated using carbon 14. Killing cancerous cells, I believe, is your cobalt. Analyzing rocks, uranium, and groundwater is chlorine. You should be able to get that from the tutorial. Okay. Now, the last thing we got to talk about is finding the average atomic mass. So not all isotopes are found in equal quantities. So carbon 12, carbon 14, carbon 13, it's not like 1/3 of them are carbon 12, 1/3 are 14, 1/3 are 13. That's not how it works. Okay, they come in different proportions. Okay, so for example, the relative abundance of the carbon isotopes, 98.93% of all carbon atoms are carbon-12. Only 1% are carbon-13, and a very, very small amount are carbon-14. Okay. Now, if we take them all together and we weigh them, we're going to get like an average mass. If we want to figure out how many atoms there are, we got to find the average mass. Okay. So in order to do that, we got to take what we call like a weighted average. Okay. We got to calculate we can calculate the average atomic mass by taking a weighted average. Okay. So the first thing here, we have lithium has two isotopes, lithium-6 and lithium-7. If we want to know the average atomic mass of lithium, what we do is we take the relative abundances from each isotope and we divide it by 100 to get them in decimal form. So we know that lithium-6 is 7.6% abundant. So 7.6 out of all lithium atoms are lithium-6. Okay, 92.4% are lithium-7. So we convert that into a decimal by dividing that by 100, and we get 0.924. Okay, so we're going to take these decimals and multiply them by their mass number. So 6.015, which is the mass of the lithium-6 atom, times its percent abundance, or 7.6%. We add that to the same thing with the other isotope. So 7.016 times 0.924, we're that 92.4%. We add those together and we get 6.9399 AMU. Okay, so that's the average atomic mass, and that's what you would see on the periodic table. So if you look at the periodic table at lithium, you get 6.94. Okay, which is about that, 6.94. And that's where that average atomic mass comes from. Okay, it's a weighted average of all the isotopes of that element. All right, and that's how you find the average atomic mass. And because we know that 6.9399 is much closer to lithium-7, even if we were told that nothing else besides this is the average atomic mass, we would know that most of the lithium atoms are lithium-7. So, okay, what else here? So you can work on this if you feel like it. Again, you can work on that. That's more questions. There's a whole bunch of questions here. Don't worry about this lesson activity because you'll be doing it in the worksheet here, so you can kind of skip over that. I have another example here for you to follow along with on how to find the average atomic mass. So step 1, 2, 3, and 4. You can do each one of those. And then there's some questions here that you can complete and turn that in. And that's it. That's all you got to do for today. If you have any questions, let me know. Make sure you do this mastery test at the end and complete the worksheet, and you'll be done. All right. I'll see you guys later.